As humanity, we have been dreaming of distant space exploration for years. Interstellar travel, however, generates a lot of problems associated with the propulsion of the right speed. The speed of light seems to be an impassable barrier to space travel. However, there is an interesting drive design that would theoretically allow the speed of light to be exceeded. Let's start with the basic issues related to the speed of light. This velocity refers to the distance that light travels in a vacuum in time and is 299,792,458 meters per second. According to Albert Einstein's special theory of relativity, this is an impassable barrier for physical objects. From Einstein's famous formula E equals mc squared, it follows that any object that would like to race against light rays will encounter some kind of break. Albert Einstein proved that energy hinders the increase in the velocity of any body, because it contributes to its mass. When trying to reach the speed of light, the mass of the object must have been infinite. At a speed equal to the speed of light in a vacuum, physical objects with zero rest mass, for example, photons. But let's first consider whether nothing is able to cross the speed of light barrier. As it turns out, the speed greater than the speed of light in a vacuum can be achieved by phenomena that do not bring information and energy, for example, a shadow. Moreover, the universe itself at the time of the Big Bang was expanding much faster than the speed of light. For many years, scientists have wondered whether there could be an elementary particle that would move faster than the speed of light in a vacuum. Such a mortgage particle was called a tachyon. Tachyons would move at a speed above light only faster than light and would additionally move backwards in time. So far, however, there is no evidence for the existence of such peculiar particles. In 2011, the world media circulated shocking information that physicists as part of the Opera project in a laboratory in Italy sent particles at a speed faster than light. These particles were neutrinos, of which as many as 15,000 exceeded the speed of light. After a year, however, it turned out that it was only a measurement error caused by a loose cable seat. It would seem that in this case there is absolutely no possibility that a spacecraft can move faster than light in a vacuum. One man, however, came up with a kind of drive that would allow him to do this. In 1994, physicist Miguel Alcubierre of National Mexico University published a surprising paper showing how to get speed over light. This article was entitled Work Drive Hyperfast Travel Within the Framework of General Relativity. The title itself already indicates to us that Alcubierre proposed a propulsion model that would not contradict Einstein's theory of relativity. Alcubierre was inspired by the warp drive, which was featured in the popular Star Trek series. The writers of this series, after consulting with physicists and experts from NASA, created a propulsion that generated a field that bent spacetime. In this peculiar way, the spacecraft was able to move faster than the speed of light. Lawrence Krauss, a cosmologist and physicist, also mentioned in his book The Physics of Interstellar Travel that it is possible to exceed the speed of light. His reasoning was that space itself could do whatever it pleased, and by bending it accordingly, we could move faster than light. Miguel Alcubierre decided to deal with this topic from the theoretical side. Every object with mass condenses the space around it, which follows from general relativity. Alcubierre did not find any contraindications to limiting the speed for the formation of spacetime. Solving Einstein's field equations, he proposed a specific model of hyperfast propulsion. A spacecraft will travel from point A to point B faster than light in a vacuum without breaking the rules of physics. In a flat, uncurved space, it is impossible to travel at speeds over great ones, but this changes when dealing with curved space. The space between 2 points can expand like rubber, which will cause the 2 points to move relative to each other. Initially, the spacecraft would reach orbit using ordinary rocket engines. Then something that Alcubierre called a spacetime bubble would turn on, which would surround the ship. In front of the ship, spacetime would shrink, and behind the ship it would expand. In the middle of the bubble, spacetime is flat, which means that the crew is safely in zero gravity. Travelers do not exceed the speed of light and thus do not break the basic rules of physics. The bubble itself can move at a virtually unlimited speed. The rings surrounding the ship would compress spacetime. In this way, the vehicle would safely reach the designated place, where the bubble would be switched off. In order for such a propulsion to exist, it is necessary to obtain a negative curvature of spacetime associated with one mass and gravitational repulsion. Scientists speculate that such properties would have so-called exotic matter and would have to be disposed of by activating the Alcubierre drive. According to the logic of the Alcubierre, the ship could move freely in a dense space, crossing huge distances in a short time. To better imagine all this, the whole drive can be compared to such a situation when we mark points A and B on an inflated balloon. Between these points we mark the point C, which symbolizes our ship. When we gently press the balloon on one side, the balloon spacetime will shrink on one side and expand on the other side, making the ship approach one end of the balloon. In theory, everything sounds great. Alcubierre was praised by other physicists for such an interesting propulsion model that does not contradict the theory of relativity. Everything is correct here, and theoretically we have a propulsion model that in the distant future would take people to the stars in an extremely short time. The problem, of course, would be exotic matter. This is a hypothetical concept of particle physics. Any type of matter that does not conform to the classical model or did not consist of baryons. In turn, Russian physicist Sergei Krasnikov believes that generating a bubble would be impossible without confirming the existence of tachyons. Interestingly, these crazy concepts of Alcubierre went beyond the usual theoretical model. Already in the years 1996 to 2002, NASA conducted conceptual research on this type of propulsion. The research was limited to a review of the existing scientific literature and theoretical considerations. These works never went beyond the theoretical and conceptual stage. In 2010, however, there was a breakthrough as physicist and engineer from NASA Dr. Harold White announced that he was working on the concept of such a spacecraft. Dr. White, head of NASA's Advanced Propulsion Team, even showed designs for the appearance of a spacecraft that would fly faster than light. This ship was named X Enterprise and would work on exotic material. The spacecraft would have two thick outer rings that would generate a field for warping spacetime. The space inside the ring would not be optimized to accommodate a lot of space for cargo, crew, and equipment. NASA researchers are to use an experimental plasma engine, the so-called Kifroster, which the Needleworks laboratory is working on to create the energy that pushes spacetime. If all is successful, the curvature will be detected using an instrument adapted to measure the speed of light of the Michelson-Marley interferometer. Miguel Alcubierre is watching these works with interest, but in his opinion, mankind will be able to create a ship with such propulsion at the earliest in the next century. The Alcubierre drive definitely works on our imagination. The thought of ultra-fast interstellar travel straight from science fiction could suddenly become our reality. As Dr. White points out, such a drive would allow us to travel to Alpha Centauri, more than 4 light-years away, in just 2 weeks. The Alcubierre drive would cleverly warp spacetime without breaking the laws of physics. Of course, for now, such a project remains in the sphere of dreams. However, 200 years ago, it seemed an impossible dream to fly a flying machine from Paris to New York in 9 hours. The Alcubierre drive is an example next to time dilation that shows us that interstellar travel is possible. Write in the comments what you think about such a project. Subscribe for more.